Stoichiometry is the relationship between the relative quantities of substances that take part in a chemical reaction, like when a compound is formed. And so here we have 20 different equations here that the reactants, in other words, the elements or compounds on the left side of the reaction, are logical. In other words, sodium can exist. Metallic sodium will exist in nature. Sodium nitrate is also logical. And the products, the ones on the right side of the equation, like sodium oxide and nitrogen, are also logical. What stoichiometry does is it allows you to, or it is the process of balancing the equations to make sure that the elements on the left side match the elements on the right side. So it's important to understand that this arrow here really is like an equal sign. In fact, it can be a double arrow because all chemical reactions are, to a certain degree, reversible. So the first thing you want to do is you want to look for something which is found in one reactant and one product, because that relationship is going to be fixed. So if that exists, you're going to start from that point. So here we have sodium in two different places on the reactant side, and so we would not start with sodium there. We're going to look at nitrogen, and nitrogen exists in one reactant, and it exists in one product. So we could start with that one, or we could also start with oxygen, which is found in one reactant or one product. So either nitrogen or oxygen would be a logical place to start, but oxygen would be a better place to start in this case because nitrogen is an elemental form and it can be balanced at the end without upsetting any other balances. So if we look at this and we see that there are 3 oxygens on this side and there's only one right here, if we put a coefficient of a 3 in front of the sodium oxide, then we can see that the oxygens are balanced. Now, if we do the count on the sodiums, we'll see that the sodiums are also balanced. There's 2 sodiums here, and there's 1, 2 sodiums on this side. So those are both balanced. And now we just have to balance the nitrogens. And since there is 1 nitrogen here, and there is N2 here, if we put a 1/2 in front of this, then everything balances, because 1/2 of 2 gives me 1 nitrogen, and that's balancing right here to 1 nitrogen. Now, typically speaking, most books don't mention the use of fractions. In fact, they say that stoichiometry should refer to whole number ratios. And that's convenient. People don't like to use fractions, but fractions really help you in terms of balancing a reaction like this. Now, you can remove all of the fractions and so forth. Right here, we're just going to put the equation again up on the top, and this time we're just going to balance them out. So instead of, we'll multiply everything by 2. So 2 times 1 is 2, 2 times 1 is 2, 2 times 3 is 6, and 2 times 1/2 is just 1. Now, it's not necessary to put the 1 there, but it does emphasize the fact that it's all balanced at this point. So let's repeat this process of some other reactions here, and let's just look at the next one here. So the next one here is taking sodium plus oxygen and going to sodium oxide. Now, in this case, both sodium, Na, right here, and on this side here are found in just one reactant and one product, and so is oxygen, found in one reactant, one product. So it doesn't really matter a whole lot where we start here, but we're going to put a 2 in front of this so that the 2 sodiums on this side balance the Na2 on this side. So we have 2 sodiums on both sides. Now we have 1 oxygen on the right side, and we have 2 on the left side. Again, we can use fractions once again. We'll put a 1/2 right here, and it's balanced. So this is a balanced reaction. Now again, to reduce the fractions, we'll just paste that in a second time here. And we can multiply everything through to get rid of the fractions. So to get rid of a 1/2, we'll just multiply everything by 2. So this becomes 4. This one here becomes 1, and this becomes 2. And now this becomes a 4 to 1 to 2 ratio. So if we look at this, there's 4 sodiums here. There's 2 times 2 or 4 sodiums here. There's 2 oxygens here. And we have 2 times 1, so 2 oxygens there. So once again, we're balanced. So this process works through from almost every chemical reaction you're ever going to see in high school chemistry. And it would be helpful perhaps to illustrate it with some other examples. So let's go down to a little bit more complex equations. So for example, the oxidation of glucose, which would be like which takes place in respiration. So we're just taking oxygen and we are oxidizing glucose, and of course energy is going to be released from this reaction and captured ultimately in the form of ATP in the body. But for just balancing this reaction, we're going to find something which is found in one reactant, one product. Well, we're definitely not going to use oxygen because the oxygen is found in 2 reactants, and so that disqualifies it. We wouldn't want to start with anything which is found in more than one reactant or more than one product, because then the ratios are not fixed from the beginning. By contrast, if you start with something which is found in one reactant, one product, like in this case carbon, which is found only in glucose and only in carbon dioxide, then I know that if this ratio has to be a 1 to 6 ratio, there's no other way it can exist. It might appear as 2 to 12 or 3 to 18, but those all reduce down to 1 to 6. So now my carbons are balanced. I have 1 times 6 on this side, which gives me 6 carbons, and I have 6 times 1, which gives me 6 carbons here. I'll then proceed to work with anything else which is found in one reactant, one product. And here we have hydrogen, which is found just in glucose, and there happens to be 1 times 12, or 12 hydrogens here. And there's only 2 here, so if I multiply everything through by 6 here, that's now going to give me a total of 12 hydrogens here, which is going to balance the 12 hydrogens there. So now we go to oxygen, which is more confusing because it's found in 2 reactants and 2 products. But we balance elemental things last because we can change the ratio of an element without changing anything else. So here we're going to count up, there's 6 times 2, or 12 oxygens there, plus 6 more here, which gives me 18. On this we've only had 6 right here, so it remains 12 remaining. So if I put a 6 here, now it's going to give me my remaining 12. So now in terms of oxygen, 6 times 2 is 12, plus 6 is 18. On this side we have 6 times 2, which gives me 12, plus 6 times 1, which is 18. So now the oxygen is balanced as well. There's no fractions in this one, so there's no need to remove the fractions because it's already in just the form of simple integers. Let's look at something more complex. We're going to look at number 13 here. So we have this long chain hydrocarbon, C18H38. And this would be fairly difficult to guess the relationship here, but it's very easy to predict. Again, if we start with something which is found in one reactant and one product, and in this case, hydrogen is found in one reactant, one product. We see hydrogen here is 38. We see hydrogen only existing in water on this side. So if we know that the reactants and the products are correct, then we can go ahead and assign the coefficients. I'm going to put a 1 in front of this. Just again, the 1 doesn't change anything, but it just reminds us that we have indeed already gone through the balancing process. So there's 38 hydrogens here. If we put a 19 in this one as a coefficient in front of the waters, then 19 times 2 hydrogens is going to give us 38 on that side. So now that is balanced. The next thing we're going to go with is carbon, because carbon also is found in just one reactant and one product. So this is already has a coefficient, so we know we've already balanced that. We don't want to change this coefficient. We won't need to. There's 18 carbons here, And the only way we can get that to balance is if we put an 18 here. And so now the carbon is balanced, the hydrogen is balanced, the thing which is remaining is the oxygen. So to balance the oxygen, what we're going to do is we're going to look for how many we have on the product side. So we have 19 times 1, so there's 19 there. And we have 18 times 2, so that's 36 plus 19, which is going to give us 55. Well, the only way we can balance over here is to get an odd number is to multiply it by a fraction. So we're going to say 55 halves O2, and now 55 halves times O2 is going to give us 55. So what we have to do at this point now is simply reduce out all of our fractions. So again, we can take this equation here, just copy it over, and now we'll multiply through by the 2 to remove the fractions, and so this gives us 2 of C18H38. That'll give us 55 O2s. It'll give us 38 waters, and it'll give us 2 times 18, or it's going to give us 36 carbon dioxide. So once again, we're balanced. Very simple way to do this, just following through with the logic in the equations.